Okay, here we go. Quad tutorial number 12. So we look at the first problem, we notice something different right away. It's not a trinomial. It is quadratic, but it's not trinomial. It's a binomial. So we probably expect that if it's not a trinomial, we're going to have to find a different way to factor it and solve it. Well, here's the deal. Let's say that this was just a problem on its own. We already know how to solve this problem. So I'm going to remind us of one way. So let's go ahead and split the paper in half. I'm going to remind you of one way that we already know how to solve it. I'm going to rewrite it, so go ahead and do that. I'm going to go ahead and try to isolate the x because we did this, right, in Quad Pack 1. We isolated the x squared, right? And then what did we do? We got rid of the square by taking the square root of both sides, remembering to put the plus or minus in front of the square root of 25. We remember that the square root and the square cancel each other out, and that we bring down the plus or minus, and the square root of 25 is 5. So that's one way to do it. But wonder if this problem occurred and for whatever reason the test or a person asked you to solve it by factoring instead of by the square root method. I want to show you that second way so that you know and you can be prepared. When we look at the left side of this equation, what we're looking at is called the difference of two squares. Go ahead and write that down somewhere. The difference of two squares. And what does the difference of two squares even mean? Well, if something is the difference of two squares, it means that there are two things, right? Both of them are squares. Another way to say that is they're perfect squares. So let's look at x squared. Is that a perfect square? Can something by itself, something times itself equal x squared? Sure, x. So x squared is considered a perfect square. How about 25? Can something times itself equal 25? Sure, 5. So 25 is considered a perfect square. When we think about perfect squares, I know you talked about that in middle school. When we think about perfect squares, we're thinking about 4, right? Because 2 times 2 is 4, or 9, because 3 times 3 is 9, and 16, 4 times 4, right? 100, 10 times 10. So we have to have two squares, and difference means subtraction. So when we see that we have two squares and the subtraction sign, we can factor it in a different way than how we've been doing with the trinomials. I know what you're saying. I can just hear it through this video, through your Chromebook. You're saying, I already have one way, Miss Overby, to solve it. Why would I want to learn a second way? Well, I have to tell you that in advanced math that you're going to take next year and the year after and the year after, you do have to be able to recognize when you have the difference of two squares, and you do have to be able to factor it. So why not learn it now, especially if it asks you to do it on this test. So here we go. We're still going to set up our two parentheses, just like we did when we had a trinomial. But we're going to ask ourselves different questions. We are going to put that x here, and instead of saying what two numbers, you know, it's funny as I'm teaching it, we could make this a trinomial, but I think, and we will in just a second. Let me stop and make this trinomial. Are you guys okay with if I rewrote x squared minus 25, instead of writing it that way, if I rewrote it as x squared plus 0x, because that's the term that it's missing, right? Minus 25, then guess what? I wouldn't have to explain a gimmicky way to understand this. We could factor this, right? As long as you're in agreement that this is the same thing as x squared minus 25. Now we have a trinomial. We can set up our two parentheses. And what are we looking for? We're looking for two numbers that when multiplied together equals negative 25, but when you add them together, they equal 0. Well, the only things, we don't have a lot to work with here. So I'm thinking about positive 5 and negative 5, right? 5 times negative 5 is negative 25. 5 plus negative 5 is 0. So that's what we're going to put here. So if you want to, and you don't want to learn something, not that it's gimmicky, but if you want your brain to understand where it's coming from, every time you see the difference of two squares, you can put in that missing middle term of plus 0x. And you can factor it the way we factor our trinomials, because you guys are good at that. Or you can just remember that we're always going to have a plus and a minus, and the second number, the second term that we put in each of our binomials is going to be whatever the square root of our number is. Square root of 25 is 5. So either way you want to remember it, this is how it makes sense to your brain, but we can also remember that we can go straight to this method. So let's go ahead and do a marker board. And you know what? If you're a little confused by that, because I give you so many ways to do this problem, right? 3 ways to do this problem. Oops, but I didn't finish it, did I? This is going to be what? X equals -5, x equals +5. Why am I running that +5? I don't know. The absence of the negative implies that it's positive. These two are the same answers, right? All right. If you're feeling good, go ahead and pause it for the marker board. Otherwise, you can just do the marker board along with me. I recognize that I have 2 perfect squares. I have x squared, that's considered a perfect square, and 100, that's also a perfect square. When I recognize this, I set up my 2 parentheses. I put my x here, my x here. I will always have a plus, I will always have a minus, and my numbers that I put here is the square root of the number. The square root of 100 is 10. If you didn't like that, you can always take the time and write it like this, and that will make sense to you. All right, I'm going to set that equal to 0, that equal to 0, and I'm going to get that I have -10 and +10. For those of you that are like, Miss Overby, I want to solve this using the square root method, I'm cool with that unless a test specifically asks you to solve it by factoring, okay? You're going to have to follow those directions. And the reason why, once again, is you are going to have to know how to factor the difference of 2 squares in the math in the following years at North and in college. All right, let's see, which way am I going here? Oh, look at that. I have 1 problem and 2 marker board problems. All right, that's good. Go ahead and pause and then come on back. Okay, so hopefully on your, I'm going to pause to take this call, so hold on and we'll finish. Okay, let's go ahead and finish. I think we were just on the second, my mic is off. We were on the second marker board problem, and so hopefully you've already paused and you're back, and you're just waiting for me to clip on my mic. All right, you factored it. It's x plus 7, x minus 7, and that means that x is either equal to -7 or +7. All right, I think that's it. I think we made it. Let's see. Yay, we made it. All right, see you in the next tutorial.